coining a balloon. This is the experiment we're gonna do today. We are gonna talk about the first Newton law.
Before starting our video of the experiment, we have to know two basic things for a proper understanding of it, which are what Newton's first law establishes and what is gravity. Let's start by knowing the first law of Newton. This law states that an object will remain in rest or in uniform rectilinear motion unless a force acts on it. Then we have gravity, which is the universal force of attraction that acts between all matter. Anything that has mass also has gravity. Objects with more mass have more gravity. Gravity is also weakness with distance, so the closer the objects are to each other, the stronger their gravitational pull will be. Once we know these key concepts, we can go on to see the experiment that we carried out.
The materials for this experiment are balloons and coins, just those two items. So, what are we going to do? We're going to put the coin inside the balloon until it is on the bottom of the balloon. Then, once it is finished, we need to blow up the balloon. We need to start blowing it until it has an accurate size. Then, we grab the top of the balloon by putting the palm of it and start spinning it. And this is how the experiment is done. Coming up next, Emilia Perez will repeat the same process as Andrea Peña just did in the experiment before. But in this case, Emilia Perez will have different coins with different weights. So, after performing this experiment a couple of times, the team deduced that Newton's first law of motion theory was proved. And why is this proved? Well, because Newton's first law of motion is often stated as an object at rest stays at rest and an object in motion stays in motion with the same speed and in the same direction unless acted upon by an unbalanced force. And how is this theory and Newton's first law of motion related to our experiment? Well, because once the person stops spinning the balloon with his hand, the coin inside of the balloon keeps spinning with the same direction at the same speed and velocity. That's how this theory and Newton's first law of motion is proved on our experiment.
So, as you can see in the experiment, the amount of time the penny keeps moving depends on its mass and the amount of pennies in the balloon. So as we can see in the first attempt, The 1 cent spins for about 25 seconds. Then in the second attempt, the 5 pennies spin for almost 24 seconds. And then in the third attempt, the 2 euro cents spin for 16 seconds. So we can see that the higher the mass and the higher the amount of pennies, the lower the time it will be.
After we did the experiment several times, we conclude that the experiment was a success because it accomplished all the characteristics the first Newton law has. We need to keep in mind that it is very important to know different laws from different scientists because we use them constantly in our daily life. For this first Newton law, we have some examples, like when you are playing any sport, you are passing your force through the ball, so that's the way the ball is moving. Also, when you are using your car and it is in a certain direction and with a certain speed, the car won't stop unless you apply the brakes or you change the speed. So this is the part of an object will remain in the same speed and in the same direction unless a force modifies it. And for the last example, we have the seesaw. This is a little bit more complex, but it is very accurate too. So it is basically the way the seesaw performs. So when you are down, the other person is up, like in the image. But this is when you are applying a force to keep your body down. And when you stop applying any force, the other person goes down and you go up because of the changes in the force. So as a final conclusion, we can say that the first Newton law was the best to describe the process and the actions that happen in the experiment, and we are very grateful for having your time, and we hope you enjoy our video.